Everybody, welcome back to another fun and exciting Algebra 1 class. Today we are starting chapter number 12. Yay, you made it! Well, this is the last chapter. You haven't made it to the end of the chapter yet, so you're almost there. Keep working hard. But you have made it to the last chapter, so congratulations. This has been a long, hard year. Algebra is one of the hardest classes that you will ever take. Algebra 2 is hard, but it's actually easier than Algebra 1 because you already know what's going on. The problem with algebra is you have no clue of what's going on, and you have to learn it all. So keep working hard, finish out strong, and find great success here in this last chapter. The last chapter starts on page 452, 452. It's called, this chapter is about functions. What is a function? Well, a function, the easiest way for me to explain to you what a function is it's an equation, but there's something interesting about function equations. They only ever give you one answer. Quadratics are not functions because quadratics give you two answers. Absolute value, for example, gives you two answers. Those are not functions. Functions only give you one. They call them output. Okay, one output value, one answer, one solution. Let's start with lesson 12.1, direct variation. Direct variation, I wrote it down here on the screen. You can look at it. Is the output of the equation is a constant multiple of the input of the equation. Okay, how can I say this a little differently than the way the book kind of words it? When you put something into the equation, like you put a value in for x, let's say, so x equals 2, so you input the value, okay? The output value, or what you get out of the equation, okay, maybe the y value or another variable, is multiplied by something, okay? It's multiplied by 2, by 7, by 1/2, by 12, whatever the number is. That is called the constant. So when you have one of these, you have a number you're putting in, that number is being multiplied by a constant, and then you have something coming out. Let's look at this example. If I consistently drive 60 miles per hour, then the distance I travel, or the output, is directly related to the amount of time that I travel, or the input. How many hours, how many minutes, whatever it is, do I input into the driving? So how long am I sitting there driving my car? Am I driving for an hour? Am I driving for 5 hours? If you are consistently driving 60 miles per hour, now that's really hard to do, but let's say that you could do it. If you could do that for 5 hours, then your output would be 5 hours times 60, and that would be the output of the solution. That would tell you exactly how far you traveled. So the formula for direct variation is right here. It is y equals kx. Y equals kx. Now, what are all these different pieces here? The y is the output. That's the answer, the solution. I wrote that down right there, the answer. Sometimes we call this the dependent variable. In other words, it depends on something else. What does your, okay, let's go back to our illustration here. What does the output, what does the distance that I travel, that's the output, what does it depend on? Well, it depends on the input. How long did I drive? It also depends on something else. It depends on me consistently driving 60 miles per hour. If I go faster or if I go slower, that's going to change the distance. Okay? So the output is based on two things. It's based on the constant, and it's based on the input. In this case, how long did I drive? All right, the k in this formula, y equals kx, the k is the constant. Now, we don't use c, although constant starts with c. It sounds like it could start with a k, right? Has that hard c sound, that k sound? Well, the constant is the k. So when you see that k, think constant. What is a constant? Okay, a constant is a number. In this case, our constant is 60 because we're driving 60 miles per hour. Okay, that's our constant. The last thing is the x, which is the input, or it's the independent variable. What does that mean? It's your given information. It's like saying, okay, he drove 5 hours. That's what they were told. They were given that information. That is the input. That's the independent variable. In other words, it doesn't depend on anything else. It only depends on itself. Okay, it's independent. If you drove 5 hours, if you drove 2 hours, if you drove 6 hours, none of that depends on anything else. It only depends on how long did you drive. All right, next, let's look at this. So in ours, our speed, miles per hour, that was our constant. Our time, our hours driven, that was the K. And then our Y, our output, is the distance. And this is, maybe you've had this in science already. Probably you have, actually. Speed equals time, times time is your distance. So the formula is distance equals speed times time. Okay, D equals ST. And you probably had that formula before. You didn't even know that it was a direct variation problem, but that is a direct variation problem. Why? Because here's what it looks like. It looks like Y equals KX. The Y in this case is your distance. The speed is your miles per hour. That's your K. And then your X is your time. And so they all match up. So just because here's the point that I want to make here. Just because it's Y equals KX doesn't mean that all of those letters are always going to be Y, K, and X. Sometimes your Y is distance. Sometimes your K is speed. And it can be anything. It could be a number of different things. This is just one example. It could be based on velocity. It could be based on, there's a million different things that it could be based on. A lot of those things come out in science. It can be based on things like perimeter, area, different formulas. Can be based on all kinds of different things. So you just have to be open to what the question is asking you. But the base formula, and that's the key right here, the base formula is this one right here, Y equals KX. You need to memorize that formula. All right, so let's now take our example that we were using. I'm driving 60 miles an hour. And so let's put it into this chart. And what we're going to do is I'm going to show you how you can figure out what your K is. So if I drive 60 miles an hour and I drive for 1 hour, I drive 60 miles because I drove 60 miles an hour. 1 hour, 60 miles. Now, if you take this chart right here and let's say you have the X and the Y, watch what happens if I put the 60 and then I leave this as the K, and I leave this as 1. What does that equal? 1 times K is just K. So 60 equals K. This tells us right here what our K is. So for this problem, our K, and I've been kind of repeating it, but I'm showing you different ways, our K equals 60. Now watch what we can do with this K and with this X. So if I drive 2 hours, what is my output? Output is the Y. That's the dependent variable. It depends on how long I drive. Y equals K 60 times, let's drive for 2 hours. What do we get? 60 times 2 equals 120. So this one would be 120. What about 3? So now I would just change this out for 3, and now I'm driving for 3 hours. So that's 180 miles. I would go in 3 hours. We can choose any of these input values. These are the independent inputs, and it will give us a different output. Let's pick a little bit of a harder one. Let's pick 4.5, okay? So 4.5. So that's our input, okay? That's our dependent. So I want to put in 60 because that's my K, that's my constant, times how many hours did I drive? 4.5 hours. 4.5 equals 270 miles. That's how far I went in 270. And we could do that with any of those values. And I won't take the time to go through each one of those, but that's how to do it. All right, now, here's what we have here. I want to know, I want you to help me find out what is the K of this one. Okay, well, let's write down our formula. That's the easiest way to do it. Y equals KX. You can take any one of these that you want. It doesn't matter which one you select. They will all give you your K because your K is a constant, so it's the same for any of those. Let's pick this one. It's the first one. It's probably the easiest one because the numbers are smallest. So if I put in 9 equals K3, and we don't write it like that. We write it 3K, right? 3 times K. You could write it the other way. It doesn't really matter. So now what do? You're trying to solve for K. You're trying to get K by itself. You're trying to get K equals. So you would divide both sides by 3, and you would get 3 equals K. 3 equals K. So our K for this one is 3. Now, let's do another one, and let me show you what happens here. Now, let's pretend, I know you have it, but let's pretend we don't have that one. We don't have that Y output. So we need to find it. Now we would take 7 and plug it in for X, and we'd take 3 and plug it in for K. Y equals 7 times 3. Well, what is 7 times 3? Y equals 21. That's our Y value. All right. Let's do this one, and let's put in a different number here. Let's put in 20. Well, let's do Y this time. Let's put in a 9. Okay, so we'll put a 9 in there. We want to know, actually this one's A and B, so B is going to be our Y, or B is our output variable. So B equals our K, our constant, times our A. Well, we don't know what our A is, and to be honest, we don't even know what our K is. So how are we going to find that? Well, we go back to one of these where we have both variables, and we plug it in. So 2 is the output, K is the constant, and A is 8. You could write it like this if you want. So I'm going to divide both sides by 8. That's going to cancel, and I'm going to get K equals, and I reduce that fraction to 1/4. Whoa, K equals 1/4. It equals a fraction. Is that possible? Yes, it's possible. It's no problem. K equals 1/4. So now, let's go ahead and plug in. Now, what we want to know is we want to know our 9. What is this going to be? What is our input if our output is 9? So just plug it in. Where does the output go? It goes into B. Where does the K go? It goes right there. So we're going to have 9 equals 1/4 A. We want to get our A by itself. So we are going to divide both sides by 1/4. That cancels that, and I get A equals this. Well, what is that? I don't know. Let's do it. 9/1 divided by 1/4. How do you do divided by 1/4? Well, you flip the second fraction and you multiply. 4/1. 9 times 4 equals 36. So in this case, A equals 36. So 36 would go there. Okay. Let's do this now in like a story problem. It's going to work out the same way. There's not going to be any real change, I guess, from what we've been doing. But yeah, let's go ahead and try this. So the perimeter P of a regular polygon varies directly with the length of the sides S. Find the constant of variation K when P equals 24 and S equals 3. So it's kind of like the same thing. It's almost like we were, had our little chart and our little box and everything, but we don't here. So the first thing that we need to do is write our formula. So Y equals KX. Now we need to figure out, okay, which one's which? Well, in perimeter is the output. Why is perimeter the output? Because the output is like perimeter equals, you know, 2L plus 2W, right? So perimeter is the output. Perimeter is the answer. Remember when I told you that the output is the answer? So in this case, perimeter is going to be our answer. So we're going to have P equals, what's our constant? We don't know our constant yet. So we have K X. What's the input? Well, when I just did that formula, the input is the sides. So the S is going to be our input. All right, so now we just input these figures in there and we solve. So if P equals 24, K is the unknown, we don't know that one yet, times 3. We would just divide both sides by 3 and we would end up with 8 equals K, or K equals 8. So what is our K here? K equals 8. Let's do one more. And this, if you're wondering where I am in the book, sorry, I kind of left you in the dust a little bit there. I am on page 454 right now, 454. I'm going to do example 12.1D. We'll do one more example, and then we'll be done with this lesson. On this one, distance, D, varies directly, so D is our output, with the square. Now that's interesting right there, the square of time. So what does that mean? Equals K, that's our constant, and T for time, but it's time squared. Interesting. You got to write what it says. If it says the square of time, we got to write the square of time. If distance equals 32 and time equals 2, what does K equal? Well, just figure it out, solve it. Okay, how do we got to do this first? So K times 4, 32 equals, divide both sides by 4, and we find out that K equals 8. Okay, and now what do we do? Well, let's keep reading. Find the constant variation. Okay, we found that. And then find D when T equals 6. Okay, so now what we want to do is use our constant of variation back into the original. So now we're looking for D. So now we got D equals, and then we do have our K because we found our K. Our K was 8. So now we have 8 times 6. That's a simple equation right there. Okay, but we have to remember that it's not just that, it's squared. Don't forget that squared. So a lot of you are going to want to put that back in there and just say, oh, 8 times 6, I know that, boom, got the answer. No, it's 6 squared. So now we have D equals 8 times 36, and then 8 times 36, we would come back over here to the calculator because I don't know that one. So 8 times 36 equals 288. So our answer would be 288. That's the distance that we would travel, 288 feet in this case, because in the question in the book, it says that distance is in feet. Okay? All right, that's fun, right? A lot of these, I like these distance and variation and speed and all this stuff because it's kind of simple. You just plug it in, work it, and then boom, you get the answer and it comes out. You can use your calculators, and so get that formula memorized and then plug into that formula, and you shouldn't have too much trouble with these, okay? All right, we'll see you later. Have a good one. Bye-bye.